Here's a polynomial problem, which was actually a question given to students taking the high-level IB Maths exam. So we're given this product of actually two polynomials, and we're asked to find the values of q and p, which seem to be some unknown variables. Okay, and that's all we know. So if you are a student taking the IB exam in maths, and if you'd like to see anything similar to this on the channel, let me know in the comments. So to solve this, I would first of all try to expand it to brackets. Okay, so for the first bracket, I would have 1 plus 3x plus 3x squared. So this is just a standard way of expanding. You can use the binomial theorem, but we'll just use just a standard way without n choose k. Okay, and the other one is going to be 1 plus, and then you have 4px plus 6p squared x squared plus 4, and then we have p cubed x cubed, and then we have plus p to the 4 x to the 4. Okay, and this equals that thing. So 1 plus qx plus 93x squared plus and so on, and p to the 4 x to the 7. Okay, so they are not actually expanding the whole thing on the right hand side, right? So they're expanding it, but they're only giving us a few terms that we can use. So the idea here is to use the fact that for two polynomials to be equal to each other, the coefficients of each term must be equal to each other as well. So in other words, if we fully expand the left hand side, the coefficient of x to the 1 must be equal to the coefficient of x to the 1 from the right hand side, which is cubed. Okay, so let's try to see, without necessarily expanding everything because it's going to get messy, let's try to see what the coefficient of x to the power 1 is going to be. Okay, so let's see, we have a 1 here, so this is multiplied by 4px, so this is going to give us 4p to begin with. So I'm going to make a note here that we're looking for the coefficient of x to the power 1. Okay, so we have 1 multiplied by 4p on one hand, and that's it with the 1, right? So if you multiply this one with any other term on from this bracket, you're not going to get another x to the power 1 term. Okay, so we're going to move on to this, to 3x. So if we multiply 3x by 1, we're going to get what we're looking for. So we're going to get another coefficient, or another part of the coefficient for x to the power 1, and that's it. Okay, so you can convince yourself by actually expanding the whole thing that this is the coefficient for x to the power 1. Okay, now the other thing the question gives us is this. So we have 93 as the coefficient of x squared. So let's try to see what the coefficient of x squared is. So let me get rid of those first of all. So what you can see is, to get the coefficient of x squared, we can do a few things. So we can multiply 1 by 6p squared x squared, which is going to give us just 6p squared as a part of the coefficient that we're looking for. And then we can multiply 3x by 4px, which is going to give us plus, and then 12p. Okay, and finally we have this, which we can multiply only with this to give us plus 3. And that's it. Those are the coefficients of x to the power 1 and x to the power 2. And again, for two polynomials to be equal to each other, we must have that this coefficient has to be equal to q, and this coefficient has to be equal to the coefficient of x squared on the right hand side, which is 93, like this. Okay, so let's try to solve this. we have 4p plus 3 equals q, and then we have 6p squared plus 12p plus 3 equals 93. So there we go. So we have two equations and two unknowns. They're not linear equations, right? Because this has p squared in it. So what we can do is we can solve this quadratic first of all. We have 6p squared plus 12p and then minus 90 equals 0. And then what I would do, just to simplify it a bit, I would divide everything by 6. Okay, so we have p squared, and then we have plus 2p, and then we have 15 equals 0. Okay, and so this is just a quadratic, which has the solutions p1 2 equals minus 2 plus or minus the square root of. So the discriminant is going to be the square root of 4 plus 60 over 2, like this. Okay, so p1 will be minus 2 minus, so this is square root of 64, the discriminant being 64. So that's a nice perfect square that we have there. So it's minus 2 minus 8 over 2, which is minus 5. And p2 is minus 2 plus square root of the discriminant 8 over 2, which is, so 6 over 2, 3. So we've got two solutions for p, and this is what we therefore have. So if p is minus 5, then q is going to be given by this. Okay, so 4p plus 3. So 4 times minus 5 plus 3, which is minus 17. And then if p2 is equal to 3, then q2 will be 4 times 3 plus 3, which is 12 plus 3, which is 15. So there are two solutions, or two sets of solutions. The first one is, if we write them like this, so p and q, they can be equal to minus 5 and minus 17, as well as 3 and 15. Okay, so those values of p and q satisfy this equality that was given to us at the beginning. Okay, one note, you are not actually allowed to use calculator for this question. Okay, so this is one of the approaches that you can take, and that's the end of the question.